All right, this is the Check Your Understanding for Section 4 in Unit 4. So the first question says, for each of the following questions, A, B, and C, we're going to find the tape diagram that goes with it. So I'm going to separate these so we can kind of better see what's going on here. So we have A tape diagram, B, and C. So the first situation says Isaac hiked X miles and Sadie hiked 3/4 miles more than Isaac. So we know that Isaac was X. And we're breaking Isaac's up into fourths because Sadie hiked 3/4 more than him. So if we look at C, here they are giving us X. There's X. So this amount of this is X. And then she hiked 3/4 more than him. So on A, it would be diagram C. For B, Sadie reads the pages of the history assignment. Isaac reads 1/4 fewer. So that 1/4 fewer is a huge clue. He read 1/4 fewer pages than Sadie. So if Sadie read X pages, both of these are X. They're divided into fourths because it tells us we have fourths. Isaac is 1/4 fewer. So here's Sadie. She read X. Isaac read 1/4 fewer. So you see there's the 1/4 that is less than or missing. So if Sadie was X, Isaac was 1/4 less than that. Less than is subtraction, so that means that we have diagram A. For B, Isaac bought X gallons of gasoline and Sadie bought 1/3 of that amount. 1/3 of it means that if Isaac had X amount, 1/3 of it would be only 1/3 of the 3 pieces. So that means we have diagram B. Now a big part of this is being able to kind of write the variable expression for what is happening in the tape diagram. So on B, we have 1/3 of that amount. So it's 1/3 of the X. So there we go. All right, this next question says, Riley hiked 13 kilometers before stopping for lunch. Then they hiked 1/5 that distance. How far did Riley hike altogether? So I'm going to look at a tape diagram here. There is my Riley's distance that he went. It happens to be 13 kilometers, so we're going to call this 13. Then, so we hiked the 13 kilometers before stopping, then walked another 1/5 of that distance. So if we take this whole amount, we're going to add 1/5. So if I take this and I break this into fifths, I'm adding on 1 more fifth to my distance. So I had here X, then I'm adding on 1/5 of that distance. Well, our X happens to be 13. I'm using X because it can stand for anything. In this case, it stands for the 13. So I want to find all of the options that can possibly be this option. My X is 13, so I have 13 plus 13 times 1/5. That's the obvious option. So 13 and then 13 times 1/5 would be this check down here. Now we can do some manipulation to these numbers. We can factor the 13 out and go 1 plus 1/5. That's an option. So that would be here. We can add the 1 and the 1/5. That's 1 and 1/5, or we can say that's 5/5 plus 1 1/5 is 6/5. So we also have 13 times 6/5. Those are all options of what we have there. Now, another way to do this is if you're not sure, you could figure out this one. This is the obvious one. And then just see which other options, when you put them in a calculator, end up being the same. You are allowed a calculator on this section. Okay, next question here. We have Margaret picked 54 apples and Gabriella picked 1/3 fewer. How many apples did Gabriella pick? So, here is Margaret. She picked 54. Gabriella picked 1/3. So I'm going to take my 54 and I'm going to divide it into thirds. 1, 2, 3. And Gabriella picked 1/3 fewer. So if Margaret is 54, Gabriella is 1/3 less than 54. Fewer than 54. So here we have 54. We subtracted 1/3 of 54. So we can have this one. 154 minus 1/3 54. We could also factor the 54 out and say that's 1 minus 1/3. So we've got this one. And 1 minus 1/3 is 2/3. So we can also say that's 54 times 2/3. So there are our 3 options. I think the last 2 questions are the hardest questions on this review. They're pretty tricky. It uses some higher thinking that is good for you, so I'm glad you're trying it. All right, this next question says, Samuel ate 9 ounces of blackberries and Ariana ate 1/3 less than Samuel. How many ounces of blackberries did Ariana eat? So here's 9. That's how much Sam ate. Samuel, we'll just call him Sam. Then Ariana ate 1/3 less than that. So if we break the 9 up into thirds, each third is worth 3, right? So this is how much Ariana ate. Ariana is missing one of these thirds. She does not have that third. It's 1/3 less. So if Sam ate 9, Ariana ate 1/3 less than 9. So we had 9. She ate 1/3 less than the 9. That's the equation. But we can really just do this. Okay, that's 3 and 3. Ariana ate 6 ounces of blackberries. All right, this next one is a fun little review question for us. We're going to select all the ratios that are equivalent to 3/4. So the first thing I'm going to do, I'm going to find that constant of proportionality. And that's just taking the 4 and dividing the 3, which is, we'll just call that 4/3 to make it easy for ourselves. So there's our constant of proportionality. Now, what we're going to do is we're going to take each of these fractions and see which ones have that same proportion. Meaning that if we take the number and we multiply by our constant of proportionality, I almost wrote it wrong, we should get the second number because that's what a ratio means. So I'm going to take the 7.5 and I'm going to multiply by 4/3 and I get 10. Well, 10 is not 12, so this is not equivalent to 3/4 ratio. 5, 6. If I have 5 and I multiply 5 by 4/3, does that equal 6? Nope. 5 times 4 is 20 divided by 3 is some weird fraction decimal 6.67. So that one is not an equivalent ratio to 4/3. Let's look at 6/8. So if we take 6 and we multiply it by 4/3, we get 24/3, which equals 8. So that one is in fact an equivalent ratio. The next one we have is 1.5 twos. So I'm going to take 1.5. I'm going to multiply it. I'm trying to do different forms of multiplication just so we remember. It could be anything. 1.5 times 4/3, does that equal 2? And I'm just going to use a calculator because we don't have to do that too much. It does. It works out. So that ratio is equivalent. The next one is 2/3. 2/3 times 4, or 2 times 4/3, does that equal 3? 2 times 4 is 8, divided by 3 is 2.67. So nope, that is not equal to 3. And then this last one here, 2.25. If we multiply that by 4/3, we get 3. So that actually worked out. So this one is an equivalent fraction. So the best way to do this, this is how I think. You might think of it a different way, and that's okay. We find the constant by dividing the last term by the first, and then we multiply the first term by the constant, by our constant, to see if we get the second. Okay, so that's all we need to do for those equivalent ratios. Ratio is just another word for a fraction. So there you go. Okay, last question here. Wyatt ran 9 kilometers before stopping for a rest. Then he ran 2/3 that distance. How far did Wyatt run altogether? I'm going to draw a tape diagram for you visual learners. So this is Wyatt. He ran 9 miles. That's before the stop. Then he ran 2/3 that distance. So he ran the 9 miles total. Then he ran 2/3 more than the 9. So this was 9. And then we had 2/3 of the 9 that we also ran. So that is our total distance. And we can go and calculate that out. We get 9 plus 6 is 12. All right, that is it for the review on check your understanding for 7.4.4.